Ladies and gentlemen, hello everybody. I'm Sabra Ahyaten from University Abdelmalek Essaadi Faculty of the Science, Tetouan, in Morocco. It is a pleasure to be with you at the 8th edition of the AirSec 2018 conference. So my presentation is titled When the DFIG concept of the wind turbine connected to the grid. First, we will start with the scope and the motivation, then the introduction, stand-alone wind farm system DFIG modeling, after simulation circuit and the results, finally the conclusion and the perspective. We made a study on the dynamic behavior of the DFIG characteristic analysis and the effectiveness and the optimal performance to access the impacts on the output variable of the wind farm contain many wind turbines. 4. Evaluate the capability and their impacts for the pitch, angle, currents, and voltage stability of the DFIG induction generator. If we take a step back from the environmental state of our planet, one thing quickly became clear. The majority of the world's problems are in fact energy problems. The depletion of the fossil fuel pollution, ever-increasing population growth, growing demand for energy accessibility and application in modern electronic power converter have paved the way for the maximum use of the renewable energy source worldwide. The development of this resource, wind, solar, marine, hydro-biomass, in modern power generation system has increased exponentially due to the emission mainly from the combustion of fossil fuel, oil, gas, petrol, etc. Their consequences are very harmful for our planet. The purpose of this research to focus on the DFIG generator for have an exact view of distribution and the degree of fluctuation presented in the pitch, angle, current, and voltage curves. The production of the electricity from conventional energy source is a major source of the greenhouse gas emission leading to the global warming. Dynamic model for a DFIG wind turbine can be indicated in the term of the equation of a P system. The stator winding is connected directly to the grid, while a bidirectional power converter feeds the rotor winds, allowing variable frequency operation and the rotor currents. This power converter is made up of two back-to-back IGBT bridge rotor side converter or SC and grid side converter or JSC linked by the DC bus. The wind turbine is also equipped with the blade pitch angle controller that limits wind power capture and rotational speed for the high winds. The system mechanic contains of the drivetrain and the aerodynamic rotor. The model of the rotor expresses the mechanical torque extracted from the wind defined by the actuator disk theory. This torque is transmitted to the DFIG rotor throughout the drivetrain. Is represented by the well-known two masses model. In our model, two rotating mass, the aerodynamic rotor and the DFIG rotor are elastically connected via Springer characteristic by the stiffness and the damping factor of the decoupling. The four equations are indicated in the direct D quadratic Q for the stator voltage coordinated motion from the turn synchronous speed, where U represents the voltage, E represents the current, W represents rotating speed, the dynamic magnetic flow, R represents resistance, and L inductance. Indexes D and Q stand for the direct and the quadratic components, and the indexes S and R refer to the rotor and the stator respectively. PW is extracted power from the wind, ρ is the air density, F the blade radius, and the omega beta is the wind speed. Cp is the power coefficient and is given as a non-linear function on the parameter tip speed ratio. Lambda is the blade pitch angle, beta is the calculation of the performance coefficient require the use of the blade element theory. The model is based on the DFIG consists of 815 megawatt wind turbine of 12 megawatts connected to a 25 kilowatt distribution system export power to a 12 kilowatt grid. The schematic represents and analyzes the simulation 1 over a period of 16 seconds and by showing the graphs of the pitch angle, active power, and the DC link capacitor voltage and the current of wind turbine. Most of the variables of interest stated above are represented in the PU value, where the base power is nominal power of each wind turbine. From the figure 3, the pitch angle starts to oscillate right after the distribution. Nevertheless, it can be seen the oscillation decays after 5 seconds, and the system is stable. However, the rotational speed decreases as well to a value below 1 pu, which means the generator rotor of the wind turbine doesn't rotate and its rotated value anymore. The behavior shows that the rotational speed is highly dependent on the wind power. From figure 4, can see that the DC link capacitor voltage show small fluctuation on the rotor active power and output power caused by the wind speed variation. It also remarks in the figure 5 and 6 that the wind farm VEBC voltage and the EBC current is the sum of the voltage and the current of the wind turbine. That means that the grid source converter is controlling wind farm DC voltage by maintaining it to set a constant value and also accruing the active power exchange from the generator to the grid. The results show the dynamic failure of the DFIG ensure the electrical distribution with the wind in terms of the grid voltage and the frequency fluctuation. On the other hand, it show also use a view on the wave offer obtain the study on the dynamic behavior of the DFIG characteristic analysis and its effectiveness and optimal performance to access the impacts on the output variable of the wind farm contain many wind turbine, which means that the adequate study for choosing the type of the control suitable of the DFIG is necessary. The continuation of the purpose of this research is to make investigation for a new type of control suitable for the DFIG control based on a new hybrid system, and the simulation of the intelligent control system will be improved and energy management among all the components of the hybrid system. We can look at further references. Thank you for your attention.